Hello everyone. Today we are gonna present about the conference paper titled "Automated Detection of Anomalous Event in Surveillance Video Scenes Using Deep Learning Techniques." As you can see, this is presentation under the module Research Methodology, and our final year project group number is 34. As you can see, these are my four group members: 4212, 4268, 4273, and 4277. As you can see, the conference paper details are there are six authors for this conference paper. As you can see, the six names, and the institution of this conference paper is NMAM Institution of Technology from India. And the conference was 7th International Conference Smart Trends Computing and Communications Conference. And this was published on 2023 November. And as 2025 update, there were two citations included in this conference paper. So let's begin by understanding the problem addressed by this research. In today's world, public safety is a major concern. There are multiple CCTV cameras, surveillance cameras in everywhere, like buildings, hospital, roads, kind of things. The challenge is current system are prone to human error, inefficient, and struggle with scalability for continuous monitoring. The urgency of this problem, rapid detection of critical events like accident or fires is paramount for public safety and timing response. From this research, from this conference paper, the solution was integrated with the CNN and LSTM deep learning models for automated real-time anomaly detection and instant alert through Telegram bots. The key advantage of this project is reduce human workload, enable immediate detection, and provide automated notification for end users. And also, these are the research of the objectives of this conference paper. First of all, they are going to develop a model with CNN and LSTM, and also this include continuous monitoring, 24/7 surveillance capability across multiple video streams, and real-time hazard detection, like identify and respond critical events like fires, accident kind of things, and also edge deployment and like implement the model on compact devices, especially for the name called Justin Nano. And also the final goal is giving the alert when anomaly is happening, giving instant alert through Telegram bot. So to continue the rest of this presentation, I invite my friend Ravishan to continue the presentation. Thank you.
Thank you. Let me now take you through the literature background and how the dataset was collected and prepared. The literature review reveals that the video classification has seen massive growth due to the rise in internet usage and video sharing platforms. Early techniques used audio, visual, and text features combined with models like hidden Markov model and recurrent neural networks. However, these traditional methods lack the ability to handle spatial temporal dynamics effectively. That's where the convolutional neural network CNN and long short-term memory LSTM comes in. CNN handles spatial features such as object and scenes, while LSTM model temporal patterns helps the system detect when something unusual occurs over time. So, the combination of CNN and LSTM forms the backbone of this research. When we talk about the data sets, high-definition CCTV cameras were placed in real-world environments. These cameras captured both normal events and anomalies like fires, accidents, or sudden movements patterns. The dataset was made intentionally diverse, covering day and night, indoor, outdoor, and different angles to make the model more robust. All the footage was stored in a centralized server. Next, the dataset underwent preprocessing. First, they had to remove the irrelevant low quality footages from the datasets. Then video was segmented into sequence with 10 frames per second. Each frame was normalized and resized for consistency. Then all clips were labeled as either normal or anomalies. Finally, the final output was a clean, structured dataset ready for the model training. For the literature part, that's all. So next, I will hand over this presentation for one of my team members. Thank you.
Thank you, Ravishan. Now I'll walk you through the model design, training, and deployment steps of this research. The approach they used is a CNN LSTM hybrid architecture. The CNN is responsible for extracting spatial features from each video frame, things like people, vehicles, fires, and other key elements. Meanwhile, the LSTM captures the temporal dynamics. In other words, it analyzes how these features evolve over time. Together, this combined model is highly effective in detecting anomalies because it captures both what is happening and how it unfolds. Next, under the model training and setup, for training, they use the high-performance setups. They are an Intel i7 processor, 8 GB of RAM, and an NVIDIA Tesla 4G T4 GPU with 15 GB of dedicated memory. The model was trained for 100 approaches and used precision, recall, F1 scores, and confusion matrices to evaluate its performance, ensuring it was robust in difference between normal and the abnormal events. Then, the deployment was done on an NVIDIA Jetson Nano. It is a low-cost, highly efficient edge device. This allows the system to work in real time, making it ideal for environments where quick detection and alerts are critical. The system works by continuously analyzing video feeds. As soon as an anomaly is detected, it triggers an alert via a Telegram bot, sending a message that includes the event type, extract GPS location, and a time stamp. Meanwhile, a live graphical interface allows operators to monitor the feed and review incidents in real time. In short, this approach is not only highly accurate, it's also portable, scalable, and practical for real-time surveillance. Thank you.
Thank you. Now I will explain the results of this research, discuss what they mean, and share the final conclusion and acknowledgements. The model used in this paper combined two powerful techniques, CNN and LSTM. They used to detect abnormal events in video surveillance. After training and testing, the model achieved an accuracy of about 82%, which is a strong result. The validation loss was low, around 0.04, showing the model learned the patterns well and didn't overfit the training data. So the F1 score was 0.8, which showed a good balance between catching true anomalies and avoiding false alarms. The model had 87% for detecting normal events and 71% for detecting anomalies. The recall for anomalies was also good at 81%, meaning it correctly identified most unusual events. A confusion matrix also used to check the model performance, and both show strong and improving results as training progress. Now let's look what worked well and what can be improved. So strengths of the system include real-time performance, which is very important in surveillance. The model can run on a small and low-cost device, which make it practical. So it also send alert using a graphical interface and a telegram bot, which giving both visual and instant text alerts with the event location and time. So however, there are also some limitations. The model's accuracy can be affected by lightning conditions, for example during night time or in very bright scenes. Also, the system has been tested on a single camera setup, and also scaling it to a larger surveillance network would require more work and resources. So in conclusion, this research all show how deep learning can improve safety through smart surveillance, and the model help detect abnormal events like accident or fire automatically, and also which can reduce the need for people to constantly monitor cameras. So it's a great step toward making cities safe with the help of AI. So the researchers thank the Karnataka State Council for Science and Technology for funding the project, and thank you for your listening.